by user needs, not by system requirements. So we want this recursive relationship so we have a place to land the indications for use and intended uses. And that's really what that's all about. And again, the capability is the systems modeling piece of this, and the user needs define how that system capability is going to be deployed, or what is the output of the capability that we need to test from a validation perspective. And of course, when we do testing against user needs, this is a validation test, not a verification test. And one of the reasons to split user needs from the requirement set is to understand the difference between those. Is this something that we're going to validate, or is this something that we're going to verify? Should it be part of the clinical trial or not? Next thing is really system requirements. And the system requirement is the output or outflow of a system function chain delivered across more than one component of the system. So by definition, when we say something is a system requirement, it's a cross-component question. And the function that we have for system requirements is defined by multiple functions, and very often or commonly those are across multiple components of the system. So we might have one component delivered by a user, another, or one component is a user, and we have a function that the user is serving. We might have a function that the software is serving. We might have a function that the hardware is serving, and all of those together are what are delivering this system function. When we do that, then the outflow of that system is really is characterized by a system requirement. So you can imagine if I have a pump and we say the pump, its function is to deliver pressure, but let's say we have to deliver a pressure that's 120 psi plus or minus a tenth of a psi, and to achieve that, it's not just a pump. Now we have a proportional valve and we have some control and whatever. And to get that output, we have to have another subsystem inside of it, right? So when we talk about a refinement of a parent-child relationship between a system requirement and a subsystem requirement, what you find is you end up defining the function, and then you realize at some point in time, I need to blow that up and have a subsystem inside of it, which has its own set of subcomponents, and I might have to do it again. And so these subsystems end up being something that we have to characterize from a system requirement standpoint, and we need to know the relationship between the high-level function and the lower-level function, so that we can characterize how this should be done, because they're going to be different tests for the different levels. So that refinement relationship is required from a standpoint, and again, from a systems modeling perspective, the functional chain is the element that we're really concerned about. Again, testing on subsystems with partial device using design end users for this testing. It can be bench testing, and really what we're just trying to do is assure that that subsystem or full system is delivering the function that or the output of the function that we expected. And one of the things about this, and I'll talk about this in the next slide, is systems can have an unlimited recursive system and subsystem relationship. So one of the problems that you run into is we don't know how many levels of subsystems we're going to have to build. It really depends on the complexity of the system and what's necessary from a risk control perspective. So we really need the ability to say, okay, we need just a system requirement, or we may need 4 levels of subsystems, just depend upon what we're trying to control. And that, not knowing what that is going into the design, is really what creates this recursive relationship. Otherwise, we would just say we have a system and a subsystem if it was always 2 levels. But it's not always 2 levels. Sometimes it's 1, sometimes it's none, sometimes it's 10, right? We don't know until we get into the system. So this is really a design report. And what this report does is it shows the relationships between the user needs, the system requirements, the design requirements, design specifications. So what is this hierarchical breakdown? And one of the problems that you run into with these recursive relationships is if I don't know how many levels of system requirements there are, I would have to create a report that would just create the columns as they're needed. The problem with that, of course, is now this report can become n number of columns wide. That's the first thing. And if I try to do it as a fixed number of levels, what happens then is I have to have every level that that's defined. And so if I do that, then I have a system and a subsystem column. That means every requirement has to have a subsystem. And that's a sort of a problem too. That's really awkward from a design standpoint. You want to do what's necessary, not extra things, just because we have a column in the report. So this is just to illustrate the kind of reporting problem that you would have. And it's worse than that because we have recursion of user needs for intended uses. We have different levels of subsystems. And in a sec, I'll talk about the design requirements as well. So each one of these has n number of columns that are associated with it. So from a deployment standpoint, we really want all of the system requirements in one column, all the design requirements in one column, and just indicate in the cells whether there's recursion above it or not. And that way we put ourselves in a position where we don't make our reporting untenable. So that's really when we have, if you think of Polarion or any ALM tool as a hierarchical modeling tool, that's really what this is. What we want to be able to do is manage the number of levels as we go in that recursion. And this is one of the tricks to sort of making sure that our reporting doesn't change depending on what different kind of device we do. And it also puts it, creates a nice management structure, and it's easy to understand for users. Okay. So design requirement. Design requirement is broken down by discipline. So one of the things that you find when you do this hierarchical breakdown is, should I specify the design discipline for each one of these levels, or should I have some place in the design that allows me to define what the discipline is? And the reason for that is when we get to risk management, we're going to be talking about FMEA structures and how to inform this data model with an FMEA structure. And the problem that you run into is that the FMEA structure is different based on the different disciplines. So software, a problem either occurs or it doesn't occur in software. The complexity is really around, there's so many different options, it's really difficult or impossible to test every different option. But if we understand the inputs and outputs, it either occurs or it doesn't occur. And so it's a 100% occurrence rate or a 0% occurrence rate. Now, when we talk about mechanical, we might have a 27.3% occurrence rate, and it changes based on how we're mitigating that risk. So the way we construct FMEAs for mechanical is different than software. And we also have special things we want to look at from a cybersecurity standpoint, for example. So these different disciplines have different FMEA structures. So level, once I understand where that function is deployed, what components it's deployed in, then I know what the discipline is. And so I can assign it to a mechanical or an electrical or a formulation discipline, and that funnels us into a certain FMEA structure. And so that's one of the things that we really need to understand is, so are we, you can imagine if we have functions deployed across multiple components of the system, it doesn't really make sense for us to say that a system requirement is associated with a discipline, right? So that's one of the problems that we really run into is, how do we do that? How do we, at what point or at what level do we start defining the discipline? And I would, again, this is comparing notes, right? This is things that I've learned as we go along. This seems to me the most logical place for us to define the discipline is at the design requirement level. So typically the testing is done on parts because it's a single component of the system, using bench testing and design staff, and defines the output of functions as it's deployed in one component of the system. So an example of the recursion and design requirement might be the system or the part will include the following colors, and then we have the colors. It's convenient not to put all the colors into one requirement, because that means you're going to have, from a test case standpoint, you're going to have to break it down in the test case. So if you want to have individual requirements for each color, then it makes sense to have recursion of the design requirement, and that's how that typically happens. Okay. So the physical requirement is really, so everything above is functional. Now we get to a place where physically we have to have something in the device to assure that design requirement is met. And an example I use for that oftentimes is sterilization. We don't want to migrate bacteria. And so the design requirement is a functional requirement that demands we don't migrate bacteria. But the way we're going to do that physically is in a bag, and maybe one side of the bag is Tyvek. So we have a requirement that we use a certain material, which is Tyvek, for ethylene oxide sterilization, and we want to make sure that that Tyvek specification makes it into the design, because that's what we're using to control whether the design requirement is met. And so what I've called these design specifications in the past. That confuses people, because what ends up happening is they think of those as outputs in the design. Really, this is a requirement that something land in the output, that the output is realized. And so we have a print and the material, or we have a part design, and the material that's specified as part of the part is Tyvek, and a certain amount of Tyvek is used. This is a requirement that says before we do the design, what that design needs to entail, right? What needs to be contained in that design. And it might be, thicknesses, it might be materials, it could be any specification associated with a part. So this physical requirement is going to be realized in a attribute of the design, and then that attribute ends up being the specification that's going to be realized in the PFMEA process. And the PFMEA process then is going to define what process controls are necessary to deliver that particular specification. So this is just tying it out from a risk management standpoint. We need to specify it because we have to test everything we have to test that it was implemented if we're using it as a risk control. Okay. And really the testing here is we're going to just look at the print or the output, whatever the output is, and assure that what we specified as a requirement actually became an output in the design. So it's just a check to see, is it there? Okay. Finally, process controls. And so each one of these physical requirements is assigned to a specification or an attribute of the design. And then from the PFMEA standpoint, we're going to develop those process controls. The testing for this is going to be the process validation. So the process validation is going to assure that those process controls are effective in controlling that design specification. And once that's done, not only have we proven that it's implemented, but it's also effective. Right? So that's the full stack. Once we do that, we've talked about labeling, we've talked about every design control there is, and also the process controls, which represents everything that we have in our toolbox that can control a risk or to assure that the design function is met. So this is the entire set. So when we back up here and we talk about requirements management, again, each one of these levels has a refinement. We have the capabilities, functional chains, and functions from a systems modeling perspective. And then we have the outputs, which are the satisfaction of those requirements. So the device at the top level is the user need, parts or subassemblies for the system requirements and design requirements, and really the part attributes are the physical requirements. And that's I got that line in the wrong place, but that the part attributes are associated with the physical requirements. Okay, so let's talk a little bit about external standards. Those external standards are important because once we have this construction, this breakdown of the requirements, we need to understand how do we take these external standards and map them in, right? How do we take something that we've done in the past or that somebody has provided us from an industry perspective and understand specifically how we're going to deploy those into our requirement set. And so the way we do that is we have really 3 different libraries or 3 different projects. The first project is the external standards project. And what we have there are a variety of different standards. They can either be company standards or they could be external, ISO, IEC, IEEE. These are all different agencies that create standards around a particular type of problem that has been identified in industry. I think BSI has some 25,000 standards under management. So each one of those external standards, so 60601, 11135, I think is biocompatibility, if I remember correctly, but essentially each one of those are broken down by clauses. And so what we want to do is we want to pull those into a library and identify each clause as a work item in the system. And what that allows us to do is then trace that clause to a requirement in a corporate standards library that's associated with the product type. And so if I have syringes or I have infusion devices, whatever it is, we have a specific way that we think about how we're going to deploy that for this product type, how we're going to satisfy that standard requirement. And what often happens too is those external standards will step on one another. So we'll have usability for 60601 and what is it? The usability standard for medical devices, they repeat themselves. And oftentimes the language isn't identical. So we really need to understand how these three requirements for sterilization are going to be satisfied by this particular requirement for this particular product type. And so that atomic traceability is really what we're trying to achieve from the external standards library to the normative or company standards. So now we have this understanding for this product type, how we're going to satisfy all of these external standards. And there might be, I mean, the last product I did, I think we had 35 standards we had to be compliant with. It's not uncommon to have several hundred, especially when you start talking about complex medical devices where you have software and hardware and all the different disposable devices, all that. So very common that we have many standards that we're trying to be compliant with. Okay, so once we understand for the product type what we want to deploy, we then share that as a document down to the product. And the product itself is its own project. And what that allows us to do is this requirement by requirement traceability. So now we have a traceability from what we expect for our product types down to the projects themselves. And the reason we do this is the projects are always different than the normative library. So there are going to be cases where we have a requirement that isn't needed. And when that's the case, if the product isn't needed or the requirement isn't needed, we can strike them. Or if we have something special, and almost always we have this new product is something special, we're going to have requirements that are deployed in the projects themselves that need to be added. So, and they're not really applicable to the company standard. Or, you know, as an example, say we're adding a guard to a scalpel. In the past, we've always done scalpels, we've never had guards. So in this case, we would add the requirements at the project level for the guards. We deploy that, get those requirements set up right. None of the other scalpels have guards. But in the future, we might say, hey, these requirements really need to be utilized by all of the scalpel designs going forward. If that's the case, then we merge those requirements back into the normative standard, and it provides us a mechanism by which we can drive out into our new product development the same set of requirements that we used for the initial set. And now we can get this sort of standardization across our product lines that's almost impossible to achieve if you don't have a mechanism for doing it. So the last question then is, from a compliance standpoint, we need to be able to run reporting that says this external standard is satisfied by this product. Here are the test cases and here are the test results that show that we are compliant. Now that we've built this traceability into the levels, this becomes trivial, right? We just specify the external standard, we specify the project, and it tells us how we're compliant and the evidence that we are compliant. And that's something that is almost impossible to do inside of a company. Very typically in these big companies, and what I've seen in the past, is we have a manual system. Somebody's responsible for those external standards. They sort of check off when the standard changes, and then we have global process owners that are assigned those standards for each of the different product types, and they have to go through their product types and understand what the implication of that standard change is. Typically takes months, it's very prone to error, and it's a manual traceability through all the different documents, which makes it very difficult to do. And so this is one of those things where we really need some automation and reporting to provide the clarity, the visibility into the data set so we understand what's implicated in each one of these changes. Okay. This is just a couple screenshots of the documents or the different template reporting structures around standards. This is the library down report. So in the library, you have a set of documents, and each one of these documents not only has the head version, but also any historical version that's been approved. So if we want to share this document down to a project. All we have to do is select the square associated with the version that we're interested in, and then we derive or branch that document down to a project. So this report makes it really easy for us to understand what should be shared and what the content that's been approved is, so that we know how to do that. Now, not only can we do this on a document by document basis, but we can also do it from a collection perspective. So let's say we had a product type and we wanted to share 30 versions, and we know what the approved versions we want to be using are. We can associate those versions, all the different document types in a collection, and share them that way as well. So this is a really convenient way for us to understand how to create a new project for a new product that we're building. What are the documents that we're concerned with, and what are the versions that we're going to be sharing? And we can share not only the head revision or the last approved version, but any historical version as well, depending on what we're trying to do. So very nice way for us to do that. And this is just an example of one of the documents, an infusion pump verification test, and it has a historical version, so we can either share version 1 or the head version as we choose. There's also a project up discussion. So one of the reports we want to be able to do is run it in a project and say, okay, what are all the documents that have been shared into this project? Where were those documents shared from? What project were they shared from? And under what revision or what version were they shared? And this also allows us, depending on what kind of documents we're talking about, we can either compare those documents, or we can, if it's a derived document, we can actually push the content down or pull it down to the project as we choose to. Now, the really nice thing about this is it does it at a cadence that the project manager wants, not at a cadence that occurs as we're approved, right? So an approval at the library doesn't force it down to the projects. It only goes down to the projects when the user at the project level, when the project manager pulls it down. And you can imagine that's a really convenient way to understand and control each product and how those requirements are realized inside the project. So we can time it in as we choose to. Okay, and this is just another view of design inputs. So this is widget PRD norms 2 that's been shared to this project, and here are all the different versions that exist inside the project. All right, so that kind of does it for today. I'm going to just give you a summary here. The first one is done. That's the one we did last week. That's now posted on a YouTube video in my YouTube channel under Design Control as a playlist. Today is the requirements management session. And again, I'll post that and email a link to it after this session is over. Not next week, but the week following, we're going to do systems modeling, and that's going to be a really great session. I encourage people to go to that because I think it really ties together a lot of these topics that we've been talking about. Any contact with me is all the information on the right. Feel free to contact me anytime. Be happy to talk to you about realization of any of these different topics and help you along your path. So thanks so much for the time today, and look forward to the next session.